Okay, so we are in the last section of chapter 1, so section 10, which is called Compare Real Numbers, and this is for Math 8. So as always, just kind of starting off the videos here, you will see a due date at the beginning here. Remember, this is the teacher preview, so I don't get to see a due date here because it's not really due for me. You always have unlimited attempts, so this is just my first of however many times I would like to come in here. This particular assignment has 10 questions on it. Grading policy is always the best score, so whichever one of your attempts has the best score on it is the one you keep. And you get partial credit, meaning if you answer 1 of 10 questions, you still get credit for the 1 question. Always, always, always click the Submit Assignment button in the bottom right corner of your page. You will not see that on my screen here because it's, again, the teacher preview, so I don't have the Submit button. But on your student screen, you will see the Submit Assignment button. So make sure, no matter what, even if you've only answered 1 of 10 questions, click the Submit button and you'll just come in on another attempt for the next time you come in. Otherwise, it's going to lock you out of every other assignment until you come back to this one. All right, when we click Start here, so we have, we always have these 3 buttons, and sometimes we have the calculator up top here. But with this one, this is the explanation. It will warn you it's going to, you're going to lose your current attempt because it's going to explain this exact problem to you with these same numbers. So it's not going to give you the answer and then let you come in and type that same answer in. You're going to have to come in on another attempt and try a different problem. Same type of problem, but different numbers. If you want to see this one, by all means, look at it. That is a very cool feature to me, that you can literally see this problem explained. You can also do examples. This opens up just a different screen here really quick. It's just a pop-up. It explains to you exactly what it wants you to do. You can look at it and say, okay, cool, I've got that. And then close it. And maybe you come back here and say, you know what, I need to see that again. The only problem is when you open this, it's not going to be the same one. It's actually going to be a different one. So it's kind of neat. You can see different examples for that same problem. And then you can also message your teacher with this exact problem attached. Okay, so let's go ahead and get started here. This one says order these numbers from least to greatest. And they gave us a calculator on purpose so that we can kind of quickly convert these to decimals. I would always do that. That's so much easier to look at if you go 9 divided by 2, so I have 4.5. And then with the second one, it's going to be, I know it's a whole number 4, but I need to know what is 5/11. So 5 divided by 11. And I'll explain why I'm doing this here in just a moment. So I'm going to write a few of these out just so that it's kind of bigger than these ones. I know it's a repeating decimal, but okay, so I'm going to go ahead and close that. So now I'm going to write the rest of these down. 5, 4, 7, 5, 5, 7. Okay. So when I'm comparing numbers, what I want to do is look at the place value. So I'm looking for the first one that kind of doesn't match. So they all have 4s on the front, so I don't really care about that. They all match, so they're all the same size. So I'm going to go to the 10th section here. I'm going to say, okay, which one is the smallest here? Well, this guy's definitely the smallest because it's a 4, and these other ones are 5s. So 4/10 is smaller than 5/10. And you can think of dimes there. If you had 4 dimes, you have less money than if you have 5 dimes, right? So we want this second number here, and if you put them in order the way that they are here, that makes it much easier too. So I can just go, okay, it's the second one. This is my smallest number. I'm going to drag it into its spot. You can also type it in if you want, but you can just click and hold. So you have to click and hold it, and then I can pull it around like that, and I can drop it where I want it, okay? Okay, so then we're going to go to the next column here, because now we know, okay, all these 5s match, so that's not helpful for the rest of these ones. Now we're going to go to the hundredths column. So I have a 5, a 4, and a 7. Well, 4 is the smallest there, so this guy would be my next one. It's my 3rd number in my list there, like that. Okay, so now we can still keep looking at this same column because they don't match. So the next one would be 5, and the next one would be 7. Oh, sorry, I've already used this one. I don't know, I'm comparing that one again. So we were only comparing, oop, I fibbed to you. Ooh, because I was still comparing this one, which I already circled. So I'm going to back up a little bit. If this is a 0 here, 4, 0, or 7, 0 is smaller, not 4. So I would have actually messed that guy up a little bit. I have to pay attention to those zeros. So 0, and then 4, and then 7. So now let's go ahead and check. Yay, we got that guy. So we're just comparing the place values here and making sure that we get them in the right order. All right. So integer, and this one might be one if you don't have your notes from class, you may either have to look it up or you could look at the example here, because we need to know, it says classify each number below as an integer or not. Well, if you don't know what an integer is, you're not going to be able to do this. So you can click on explanation. It will give you the definition of integer for this example. So it'll go below. If you scroll down, it's going to say, well, it's not directly giving us. Usually they give us the definition there, darn it. So it says an integer is one of the following numbers. Oh, it does. It just didn't actually say this is the definition. So if we look at this list, it's saying that an integer is anything 0 and above or below. But if you notice, there's no decimal places here. It's all kind of whole numbers. So no decimals. 1, 2, 3, 4, 5, -1, -2, -3, -4, or 0. So with this one, what they're saying on the example, we had -1/1. Okay, well, that actually is just -1. I know it's a fraction, but it really is just -1, so that works. -12/4, if we reduce this, 12 divided by 4 is 3, and we put a negative on it. Okay, well, that still works. There's no decimals there. But this one would not be an integer because we have a decimal place here. We have 35/100ths. We don't want that. And same thing with this. If I did 1 divided by 20, I'm definitely going to get a decimal there. So we're looking for non-decimal numbers. So we just go through and we click yes or no. All right. So with this one, 20 divided by 5, well, that's 4. That works. I see a decimal place here. We don't want any decimal places. So I'm going to go ahead and click no there. Well, +4, that was the same as this first one. So yes, that works. -5 divided by 3. If you don't know what that is, you can always grab the calculator. Oop, they don't have the calculator in here, but you can always grab another calculator if you want. And go 5 divided by 3. And go, oh, nope, that's a decimal. I don't want that. So no. -72, that's perfectly fine because there's no decimal place. So we're going to go ahead and click check there. And we're good to go. Okay, for each number, determine if it can be written as a fraction, then state the reason. That neither terminates nor repeats. Okay. All right, so this one does have a little bit of some special rules that you're going to have to know in order to do this. So I'm going to go ahead and click on explanation because I'm assuming they will have a nice little explanation for us on what to do. So this background section, this is what I'm talking about. We need to understand how to write a decimal as a fraction in order to complete this. If we didn't understand that section, we're definitely not going to be able to answer these questions. So if we go down, and the first one is just 0.92. So for this first one, it says we need to know about different decimal forms. So as you read below, remember that the numerator of a fraction must be an integer and the denominator must be an integer that is not 0. So integer means no decimal places. A terminating decimal eventually stops. So that means, like we have here, 1700ths, 333 thousandths, we have, it definitely stops. It doesn't keep going. So when you have a terminating decimal place, what we do is we just count. How many times do I need to move this over to make it an integer? So then I can write this over here. So I'd need to go 1, 2, like that. So I did 17, and the number of times I move is important because that's how many zeros I put in. So it's 17/100. If I want to do 33, then I would have like this, and I'd go 1, 2, 3 times. So I have 333 over 1, 2, 3 zeros like that with a 1 on the front. So these are pretty, terminating decimals are a little easier to put into fraction form. They're pretty simple. You just say, okay, this is how many times I need to move to make this an integer on the top. If it's repeating decimal, which we see here, now we have a slightly different piece or different process. So because the decimal doesn't stop, so we can't simply just move to the end. What we have to do is it gets put over nines instead of zeros. So with this one, they're not quite telling you that right off the bat. But if I had this same thing with these threes, but instead of it stopping, it was like this, I would go over once like that, and I would go, okay, that's 3, but instead of putting it over 10, it's over 9. And there is a formula that goes with this, but the basic idea is that it goes over 9 instead of 10 if it's repeating. And then we would reduce this. They both reduce by 3, meaning they both divide by 3. So we get 1/3, because 3 divided by 3 is 1. 9 divided by 3 is 3. So that's where they get the 1/3. So this is for repeating decimals. This is the method that we use. If it's non-repeating, or if it's non-repeating and it doesn't terminate, so it's just kind of weird decimal that just kind of keeps going on and on forever, the decimal that it neither terminates or repeats, it cannot be written as a fraction. So this is what we're looking for cannot be written. Okay, so we're just identifying it. Does it terminate? And that's easy. We put it over 1 with zeros. Does it repeat? Which means that we put it over 9s, and we reduce that if we can. Or does it neither terminate or repeat? And then we say, okay, we can't write that one as a fraction. So just a little bit of background there for that one. I just wanted to go through that because that's important. If we don't understand those pieces, there's no way we can complete this question. So here we have a repeating decimal. So that would fit in this category. I can definitely write that as a fraction, yes. And this is a repeating decimal because that's what that bar means. It's repeating. With this guy, it looks like it is repeating, and it looks like the 6s are repeating as far as I understand there. I hope that I'm looking at that correctly and they're not saying that it's going to change. So I'm going to say yes on this one, and I'm going to say it's repeating. This guy doesn't look like anything is repeating at all, but it keeps on going. So this is that one where we can't write that as a fraction. It doesn't stop. It doesn't repeat. So this is neither terminating nor repeating. This guy just plain stops. This is a terminating decimal. So that's that first one that's a little easier. We just move it over 1, 2, 3, and we'd put that over 1,000. So yes, and it's terminating. All right, let's go ahead and check it and hope we're good to go. Yay, we did that one good. So again, this was just a practice in do you understand how to turn a decimal into a fraction and the 3 options that are presented to us there. Okay. The Venn diagram shows the memberships for Math Club and Science Club. Use the diagram to show, to answer the questions below. So we have Math Club here, Science Club here, and this is both. So these 3 people are in both Math and Science Club. So how many members does the Science Club have? So we need to look at the entire circle for Science Club. So we have these 4 that are only in science, but we also have these 3 that are in both. So that's 7 total. How many students are members of both Math Club and Science Club? So that's our middle, because it's and. So that's, oops, got to scooch down here. 3. How many students are in the Science Club but not in the Math Club? So we want science but not in the math. So only the 4 that are off to the side there and only the Science Club. All right, let's go ahead and check. Yay, we got it. Okay, we're almost halfway there. So it says use the Alex calculator to approximate the square root of 135 and round your answer to the nearest hundred. So let's go ahead and pull up our calculator here. And remember, we have to type click the button first on this one. If you're using a smartphone calculator, you type the number in and then click the button. So it's just difference in calculators there. So let's go ahead and click equals. And we want it to be to 100th. So that means we're focusing on this guy here, but I need to look at the number right past it. This is definitely bigger than 5, or it's 5 or bigger. So it's going to round this up to a 2. So I need to be careful about that. It's going to be 11.62, not 61. All right, let's go ahead and check that. Continue. All right, we're back to ordering some numbers here. And they did give us a calculator again. So I would definitely suggest going through and figuring out what these are. So this first one, we have 16, but we need to know what is 3 divided by 10. If you don't know that one, you can always type it in here and say, oh, okay, it's 0.3. Don't put 0.3 on here, just 3. Instead of 0, we already know it's a 16 on the front. The next one is going to be negative, and we have to do this squared sign and then 270, and it's okay that it's negative. Go back. Equals, not plus, because the negative's outside the square root, so it's just 16.43167. I'm going out a few decimal places. I probably don't need to go out that far. 50 divided by 3 equals 16.3333. And then the last one is negative 16.5. And it's repeating, which means it's going to, keep on going here like this. And I'll put the dots here. Sorry, you can hear my kitty cat playing in the background there. She's batting around a ball. So if you can hear that, I apologize. But, all right, so now we're going to go through and we're going to start comparing. It wants us to do least to greatest. So first, let's go and focus on least. Well, I know my least is going to be one of these two, right? Because these are negatives. Oh, I forgot one of my negative signs. This is also a negative. So right away, I actually already know what my greatest one is going to be. These 3 are going to be my least. Well, 16.3 is positive. It's my only positive number. So this is going to be the greatest number. I can go ahead and just drag it over there and kind of forget about that one. So I've already used this guy. I'm going to cross him off this time so I don't make that same mistake I did on that first one. All right, so we already know that the negative 16s. We're going to ignore that. We're going to go to the 10th column here. And we want least, which since they're negative, it's actually backwards of what we think. The bigger the number when it's negative, the smaller it actually is, because we're going more negative the bigger it gets. So we're actually looking for the bigger 10th, which would be 5. So that's going to be my last number there. And then we're going to go to 4. So that'll be my second number. And then we're going to go to 3, which would be my third number there. So that should be good to go. It's not. What did I put in the wrong order here? Which one did I drag wrong? Uh-oh. And one thing to make sure, it's always a good idea to kind of make sure that you didn't type in some numbers wrong when we were doing the calculator. 16.43. That one looks good. 50 divided by 3. That one looks good. Well, interesting. Which one does it not like? So we definitely have this guy here. And then 16.5. Those should be in the right order. Well, I'm going to go ahead and I'm going to click on explanation. Oop, not calculator. Let's click on it and see what they say. What did So, let's see, 16.3. How did I get that? I must have grabbed the wrong number. Oh, I did. How did I do that twice? This should be 6's. So that's what I did. This actually should be the smallest number. And then the 5 and then the 4. So that was just an oops. Somehow I typed that in the calculator twice, 2 times. So stuff happens. You just got to make sure, definitely paying attention there. And that was an oops on my part. So I'm going to return to the problem there. For you don't have an option to return to the problem. Sorry. Only the teachers have that option. Normally, when you've clicked on explanation, it's not going to let you return here. So with this one, I can go ahead and fix this just so that we can get our little green check mark here. It's actually, I don't think it'll let me because I don't see a submit button on here. So it did take it away from me, even though it let me return to the problem. So it may still also say that same thing to you. It'll return to the problem, but you can't change anything and resubmit it. So we just definitely need to pay attention when we're writing down our dang numbers. That was an oops. Okay, so let's see. Check all statements that are true. Since it is a ratio of 2 integers, 3/9 is rational. And then, okay, so we need to know what these mean. If you don't know what rational or irrational mean, again, you're not going to necessarily be able to do this. So this is a good one to go ahead and click on explanation and make sure you understand what do these mean. So integers, remember that's whole numbers without any decimals on it. So -3, 0, 5, those are examples. Fractions, quite literally, it's, numerator and a denominator. We have terminating, repeating, which we were just practicing a moment for our decimals. Square roots of perfect numbers. So with these ones, if it's a square root of a perfect number, that means that you're actually going to end up having just a number. So the square root of 81 is 9. The square root of 1 is 1. The square root of 4 is 2. So these ones are rational. So a rational number is a number that can be written as a ratio of 2 integers. So anything in here is called a rational number. We can write it as a ratio or as a fraction. An irrational number is a number that is not rational. That is, it cannot be written as a ratio of 2 integers, or it cannot be written as a fraction. Remember, that means that we're looking for that non-repeating, non-terminating decimal. That's what we're looking for when we're looking for irrational. So square roots of non-perfect squares, so the square root of 2, square root of 8, square root of 17, these are going to have really funky decimals that just keep on going, but don't repeat. So we just want to look at, does it fit within rational or irrational? Again, we're kind of just comparing that type of decimal again, if we think of it that way. So with this one, if we have 3/9, if we divided 3 by 9, or if we reduce this, it would actually be 1/3. If we actually divided this, it would be 0.33333333 forever. So that is a repeating decimal. That guy's good to go. And it's already a fraction. So this actually helps us because if we can write it as a fraction, it's rational. This says since it is a terminating decimal, 15.9 is irrational. Uh-oh, that doesn't fit. That would fit in the rational section because that's terminating. We can write that as a fraction. Since 10 is not a perfect square, the square root of 10 is rational. Oop, this is exactly what fits in irrational. So this would definitely, we want that to say irrational to check that box. Since 64 is a perfect square, the square root of 64 is rational. That is definitely true. The square root of 64 is 8 or -8, depending on which one we're looking at, and either one works as an integer, which is a rational number. Since it is an integer, 9 is irrational. Well, that one would definitely fit in the rational section for being an integer. So we wouldn't check that box, and this is none of these statements are true. Well, we have at least 2 statements true, so we can check that and move forward. All right, a couple more here. So classify each number as rational number or an irrational number. So same idea we were just doing. There's just a little less words on this one, but we're going to go through and classify them. So 20 divided by 7. If you don't know what 20 divided by 7 is, although this is a fraction, so we should be able to do that pretty easily as far as understanding that, that idea. This guy, though, let's see, it is repeating. So I was going to say at first it's not repeating, but it is a fraction, so it should be repeating in some way. So we have this really funky repeating. It goes all the way over to the 2 and then repeats again. So it's 85742. That's what's repeating each time. So this is a repeating decimal, so it is rational. And again, it's written as a fraction, so that's helpful. As if you can write as a fraction, it's rational. Negative 64.10, repeating. Okay, well, repeating decimal is fine. We can write a repeating decimal as a fraction. The square root of a perfect square, even though it's 1, 1 times 1 is 1. So this is, the square root of 1 is 1. That guy is rational. The square root of a 26, and if you weren't sure, you could go 26 square root, and you get a really funky decimal here. There is no repeating pattern at all. So this guy is irrational because 26 is not a perfect square. And then pi, this is our kind of perfect example of an irrational number. So if I click pi, this number never stops. It repeats on and on forever, and there is no repetition to it at all. So this would definitely be irrational. All right, a couple more of these guys. Okay, so this is a diagram that we should be filling out on our notes page as well. So this just helps us identify the kind of breakdown of real numbers. Okay, so all of these are real numbers within here. So we would have, first, let's label this with, we have our irrational numbers and we have our rational numbers. So this is the two sections that real numbers are broken into. We have rational and irrational. And then the first piece we get are, I believe, integers and then whole numbers. Integers include 0, but whole numbers do not. Okay, so integers would be an example of whole numbers. If it's a decimal, then it would still be in the rational section, but it wouldn't be in the integer or the whole number section. And we were just talking about this. Pi is irrational, so that would definitely go in the irrational section. The square root of 10, well, 10 doesn't have a perfect square root. This would have a really, really funky decimal on it, so we would move this over here. Whole numbers, so this could actually go in integers or whole numbers. I'm thinking they wanted to go in whole numbers because it would be the only one that could go there. And then this one, if we divided 9 divided by 2, we would get 4.5. So that's a terminating decimal, but it doesn't fit in integers or whole numbers because it has a decimal place. Okay, so let's go ahead and check that and see if we're good. You're partially correct. Uh-oh, what did I do? Let's see. I'm going to click this. I think I might have flipped integers and whole numbers. I'm just going to peek over here really quick. Integers, whole numbers? No, I put those in the right spots. I wonder if it actually wants this one up here. Let's try again. Last try. It still doesn't like it. Where does it want me to move things? Just being awfully picky here. 20 decimals, let's see. So we labeled the regions correctly. Should each one have, I think each region needs to have one. Sometimes this is the only problem with Alex, is it can be very picky, and I'm not always sure exactly what it's picking on at the moment. Well, let's just go ahead and click on explanation here, and it'll tell me exactly what I did wrong. So it's okay to do things wrong. Let's see, we have, oh, okay, it wanted me to put the 0 down here just to have it in this spot there. I think that's picky because integers could have 0 in there. So I think the program was just being a little picky on that one. And it just kind of wanted something in each section. So that makes sense, but it's being a little picky because 0 does fit in integers. So, all right, well, I'm going to go ahead and click, return a question, I guess. Okay, so we'll continue to the last one here. I don't like these red X's. But see, this is an example. So this one shows me that I tried it a few times and I didn't get it correct. This one shows me that I just lost the attempt. So it just kind of depends on the coloring there. But those are ones that I would want to go back and fix to get 100%. Okay, last question here. Suppose a pendulum is L meters long. The time in seconds that it takes to swing back and forth is given by T equals 2.01 times the square root of L. If the pendulum is 19.13 meters, 19 and 36 hundredths meters long, how long does it take it to swing back and forth once, round to the nearest tenth? So what they're asking us to do is, well, they just told us what the length was. It's 19.36, right? So we're just plugging this in. 2.01 square root of 19.36. So we need to do this square root first. And it's probably not going to be a very nice number. So we're probably going to want to do this kind of on the calculator. Oh, I keep forgetting you got to click the button first. 19.36. And you could actually put 2.01 on the front and then times. You can type that all in at once and it's showing you the whole thing. So 2 and 1/100 times 19 and 36 hundredths, or the square root of that. So if I click equals, it'll give me the number here that I want. Remember, it said round to the 10th. So here, this 8 is my 10th. I need to look at the 4. That's 4 or smaller. So really, it's just going to disappear. So my answer is going to be 8.8 seconds. So again, this one's just to practice in plugging in a number. They're giving you a formula, and you just need to plug in the number they're giving you and complete the operations that they're giving you there. All right, so that was section 10. Kind of had a little bit of hiccups with some of the technology here, but it's one of those issues of just making sure we're paying attention, or, understanding sometimes Alex can be a little picky, and we need to kind of account for that sometimes a little bit. All right, well, I will see you in chapter 2.